next, we are going to have a wonderful guest introducer.
Surprise.
She's
So
back.
I'm up here again because Bridget asked me to put on my own DevOps Days organizer hat and introduce our next speaker. I'm one of the co-organizers of DevOps Days New York. That's going to be coming up next year sometime. And when Bridget asks me something, she's so delightful that I really can't say no. Her energy and enthusiasm really keeps me forever young. So our next speaker is somebody that I'm really lucky to get to work with on Etsy's web operations team. He's a member of the Etsy Face Metal Squad, which, unlike the pink-haired thought leadership conspiracy, actually does exist. And he's the author of Customizing Chef from O'Reilly. Gonna be talking about some more chef stuff. Please welcome Jon Cowie.
Good morning, everyone. Thanks for coming out to another wonderful DevOps Days conference. Thanks again to the awesome organizers for making this possible. Today I'm going to be talking about feedback. I'm going to be talking about chefing Etsy, and the specific focus here, because chef is many different things to many different people, is you all know the maxim, too many cooks spoil the soup, and I'm going to be focusing on whether that holds true with chef, and specifically the way we use chef, our chef workflow to try and combat this, and some of the issues and pain we're running into now, because everybody loves hearing how people aren't doing it right. So this is me. I'm a staff ops engineer at Etsy. So I'm on the team that basically I work with Catherine and a number of other very, very smart people, and we look after all the infrastructure that runs the site, all the software, the automation, everything up to the level of the code, basically. If you aren't familiar with Etsy, we're an online marketplace for handmade and vintage goods. One of my favorite ways of putting it is we let you buy good things from real people. So hands up in the room if you do not or have never used Chef. A decent number. That's good, because I'm about to start with a basic introduction to Chef. So Chef, at its most basic, is what's known as a desired state configuration management system. What that means is you tell Chef, and other systems like it, what you would like your system to look like, your desired state. Chef then goes and looks at your system, it looks at the current state, and it figures out what needs to be done in the middle to, as the terminology is converging, to converge the system to your desired state. So that's the premise of Chef. You're telling it what you would like your system to look like. Chef operates on a thin server model. The server is essentially a data store and an API and some search indexes. It doesn't handle any of the logic itself, as I mentioned there. And it operates on what's called a thick client model, where the client actually does all the work. All the dependency resolution, figuring out how to do the state convergence, that's all handled on the client side. So you have a central server, clients talk to it to get their data, and they're the bits that actually do the work. The other thing I want to do, because there are a bunch of people here who haven't used Chef, is although most of this talk isn't going to be, you don't need to know Chef to know this talk, I will be using some vocabulary, and it's helpful to frame that in the context of what it means in Chef. The first thing I'm going to define is what's called a node. In Chef, a node is essentially the box on which you are converging your state. So if the client that you want to manage your configurations on. Chef also has the concept of a node object, which is the previous state of that node saved on the server. Cookbooks are one of the things we'll be talking most about. They are really the main artifact type in Chef. They're a versioned artifact. And cookbooks are essentially where you store these instructions for what you would like Chef to converge your desired state. That's where you define your desired state. This state specification is stored in what's called recipes. There are other stuff in cookbooks as well, but that's largely irrelevant to this talk, so I'm not actually going to cover those bits. But the thing to focus on is cookbooks are where you store that state specification. We're also going to talk a little bit about a thing in Chef called environments, and the only aspect of environments that's in any way relevant to this talk is the fact that environment stores a list of cookbook version constraints. Cookbooks are versioned artifacts. Environments, if your server lives under an environment, it will get that list of cookbook versions. We're also going to talk a little bit about a tool called Knife. Knife is a command line tool for interfacing with Chef server. It's essentially an API client, and it's extensible with plugins. What it actually does isn't hugely important, but the vocabulary, when you hear Knife, it's a command line tool. One of the foundational design principles of Chef, basically, is that there is no magic pill. And this is the case with a lot of tools in DevOps. Chef is not designed for you to drop it into your infrastructure and have it automatically solve all of your problems. because you are the experts in your business. Chef are not. Chef cannot come into your business and say what you need to do your configuration management properly is to do it this way. Chef is there to give you a toolkit which lets you build that solution yourself. You are the experts in your infrastructure, and you tell Chef how you want your infrastructure to look, and Chef gives you the tools to make that happen. So with that in mind, I want to talk a little bit about exactly how we use Chef at Etsy, because bearing in mind what we just said, our use case is going to be coming from a different place than many of yours. So it's useful to frame, when we're talking about our workflow issues, the problems we're trying to solve in the first place. So we use a Chef server. It's possible to use Chef server if you're familiar, like in Puppet and so on. You can use it in like headless mode sort of thing where you don't have a centralized server. We do use Chef that way, so there's a central server. We have roughly 2,000 servers being managed by Chef. They're largely all CentOS, so we're only pretty much dealing with one operating system. We do have some Macs, which are, just for interest's sake, they're Jenkins build slaves for running integration tests for our iOS app. But pretty much everything is on-premise. That's another key factor. On-premise, central server, all CentOS. We use Chef for everything from the bare operating system to right below the code. So everything from the raw base image operating system right up to the point where we're going to deploy our application code. We do not deploy our application code itself using Chef. For that, we use an internally developed tool called Deploynator, which is open sourced on Etsy's GitHub. But that does play into the way we think about using Chef, because we aren't, although we are continuously deploying Chef code, and we continuously deploy our application code, we are not continuously deploying our application code with Chef, which simplifies things quite a lot in the way we think about it. All of our Chef cookbooks and all of the environments and all the stuff we talked about live under a single Git repository. And one of the problems we run into as a result is the fact that we essentially have two sources of truth. The nodes that are talking to the Chef server do not have the concept of Git. Git is not a supported backing store for a Chef server. So what we end up with is the source of truth that all of our computers talk to and the source of truth that all of our humans talk to. And one of the things we deal with is reconciling that potential divergence. So far, this is relatively normal. This is quite a typical Chef workflow for a mid-sized company doing, web stuff. There's nothing in here that's particularly unique to Etsy-specific workflow. There'll be a lot of you who do use Chef, probably in a similar boat. The area where we've started to run into the most workflow challenges are the number of people we have working with Chef. So we use GitHub Enterprise internally, and they support this thing called a pulse graph on your repositories, which is it's just a nice way of visualizing your activities. So this is our Chef repository for last month. We had 50 individual authors pushing 1,600 commits to all branches. What this translates to in real terms is roughly 35 Chef deploys per day. But to define exactly what a Chef deploy is, the point we consider an actual deploy is when we've updated the version constraint in the production environment, which means all of our nodes are looking at that cookbook. Before that, you've actually got the cookbook onto the server and done a bunch of other things. But this is what we're actually tracking when I say 35 deploys a day. Another factor we deal with that influences our workflow choices and decision-making extremely heavily is a lot of our Chef users are not extremely experienced with using Chef. We operate largely our entire engineering org on the principle of what the Soviets called trust but verify, which largely means we default to letting people do things, and rather than blocking them from doing it, we verify they're doing what they're supposed to be doing. So we have a lot of Chef users who maybe are making their first ever Chef change, or they make one Chef change every 6 months. They are not people using Chef day in, day out with the level of expertise that comes with that. So with all that kind of framework and constraints in mind, I want to talk a little bit about what our actual cookbook workflow looks like. So you're a developer or operations engineer at Etsy, and you have written some cookbook code. You've written some desired state, and you want it to be converged to by your nodes. So the first stage we go through is code review. As I mentioned, we use GitHub Enterprise internally, which means we benefit from a lot of features that Git has, like branches and pull requests. So we have a little command line wrapper which generates a pull request from your local development branch and lets you say, I want this pull request to be sent to this person. Here it is being sent to me, and CC the rest of the ops team. So here we have one of our developers making a Chef change. He sends me the pull request, and I say, looks good to me. And that lets, in this case, him know that someone's had a brief look at this change. It hasn't been, tested or anything, but somebody's just given this the once over and it's okay. This is particularly handy for people who are making their first Chef change, because it just gives them that little bit of extra confidence that somebody's cast their gaze over what they're doing. So the next stage is actually pushing the change onto the server. And for this, we actually use a tool we wrote ourselves called Knife Spark. This is all developed internally. And it was designed explicitly to solve this problem, or try to solve this problem, of multiple chefs clashing with each other. Because although we have more now than we ever have, we've always had an unusually high number of people making chef changes. So a lot of our workflow has grown from that. It's also designed to give us visibility into changes. As I mentioned, we operate on a trust but verify principle, which means it's very, very important to us, although we're not necessarily watching all the time, to be able to track when changes go out, what was in the change, who made it, when it happened, so on and so on. Spark is also extensible with plugins. This came from the fact that we actually discovered a few other people had the same problems, but they were using things like HipChat where we were using IRC, so there's a whole bunch of plugins you can use for other stuff. What the actual workflow looks like is a 4-stage process. The first stage is bumping the cookbook. And all that means, because cookbooks are versioned, they have a little metadata file inside them, which contains a version number. All bump does is it changes that version number. We then upload the cookbook to the central chef server. Now at this point, nothing's actually looking at it, because ideally, if everything's working correctly, all of our nodes are pinned to the previous version in the environment file. So this is kind of almost a no-op, apart from uploading things to the server. We also make use of a feature that Chef has called cookbook freezing, which essentially makes sure we can't upload the same cookbook twice to the server with the same version number. Every change is a new version number, which means we know that what was version 0.1.1 will always be version 0.1.1. It's not going to change under the hood. After that, because nothing's looking at the cookbook yet, we test the change out. I'm going to come on to the testing workflow separately, because there's a few more pieces to that. The final stage, and this is the part that actually constitutes the deploy that's tracked in 35 deploys a day, is promoting the environment file to the server. And promote in this context means adding the version constraint into the environment file, it's just JSON, and uploading that to the server, which means that all of your nodes are now looking at your new cookbook version. The final stage is actually committing and pushing to Git. As I mentioned, we have 2 sources of truth here. And we've had many, often quite heated discussions internally on whether the human source of truth is most important or the source of truth that our machine's looking at is most important, and which order this happens in. What we ended up coming down to was that the computer source of truth needs to be working more, because that's what makes us money and drives our website. So we compromise and we commit and push the code last, because then all of the servers are looking at the right thing. And really, the Git part is just useful for humans for tracking who did what and some version control history stuff. So on to testing the change. The testing workflow we had for a long time, because we had this tightly constrained production environment, was we would move the node into an unconstrained environment, so essentially an environment which had no version constraints in it. And what that largely means is you get the latest version of every single cookbook on your node. Some of you are probably already spotting a flaw in this plan. To do that, we had a little knife plugin we wrote internally called Knife Flip, which largely lets you make that change. It lets you flip a node from one environment into the other. Onto the downsides of this approach, which were many. No unit tests. Unit testing is kind of a thing these days. Like, it's generally accepted to be a fairly good idea that writing tests for code is a desirable thing to have. Holding the cookbook in the testing environment is blocking, because if you remember, we have this upload step and then the promote step. And while the upload step is in progress and you're testing in this unconstrained environment, nobody else can change the same cookbook because your changes aren't in Git yet, so they don't have them. If they want to change the same cookbook, they're essentially hurdling your testing change, and they've uploaded a new version which is their changes but not yours, and now your node in testing is getting their changes and yours just vanished. And like, that causes some friction. One of the most obvious problems is the testing environment affects all cookbooks. The node you just flipped into testing is now getting everybody else's changes too, because all of a sudden you're not constrained. You're getting the latest version of everything. That causes some surprises occasionally. We have an interesting story about accidentally upgrading MySQL across the entire site, largely because of something like this. Luckily it worked. There's a fairly well-known saying there, but for the grace of God go I. That's largely what happened there. To get around this, we found people were often using upgrade environments. Largely, that is an environment which contains all of the constraints except the one for the cookbook you're testing. What that leads to is environment sprawl, which nobody cleans up because the test works, so you just move on with your day and then you go and do other stuff. So you end up with a whole bunch of environments But then what you end up with is you forget to flip a node back from a constrained environment because everything's working fine, and all of a sudden you're getting all the changes for one cookbook and none of the changes for all the rest. Again, this causes problems. So we sat down to try and figure out how to make this more Etsy. Etsy talk a lot about continuous deployment, and we do things like in our main site code, we do things like we have feature flags to turn on and off features selectively. We ramp up features. We do A/B bucketing for testing out new features and stuff. And the way we were doing our chef testing really didn't feel very Etsy. It actually felt quite annoying, and it was extremely frustrating to deal with. I wrote the workflow, and it was pissing me off as well. So what we came up with was a thing called Chef Whitelist. This is essentially driven by JSON data. It approximates what we get with feature flags, but it lets you specify some JSON data that describes the content of a whitelist, which are going to get your changes. It's driven by a thing in Chef called cookbook libraries. Chef allows you in your cookbook, as well as these recipes, to effectively drop in extra functionality via Ruby classes, which lets you extend all manner of things in Chef for good reasons and bad reasons. But it does let you add that extensibility in without having to modify core code or anything. What this gave us was the closest we can really get to having feature flags in our Chef infrastructure. So a whitelist looks something like this. This is actually the real whitelist, or it's an abbreviated version of the real whitelist we use for upgrading a PHP 5517 internally. You specify a whitelist name, and you specify a list of regex-based patterns that tell you the hosts you want this change to go onto. When you're running Chef on a node, it has the concept of what its own host name is. Like the node that is currently running Chef, you can say, what is my host name? What is my IP address? Things like that. And then in your recipe code, it lets you do something like this. You can say, if node is in whitelist PHP 5517, in this case, uninstall the package PHP pickle opcache. What this lets you do is you effectively now have feature flags. All of your changes are now in Git because you don't need to hold them in testing in this testing environment. You push them straight to Git and you control what's actually getting the change by adding and removing things from your whitelist. Similar to how if we want to turn off, say we get paged for something and have to turn off a feature on the site, we can flip off the feature flag, commit and push the change to Git, and that doesn't interfere with all the other people who have experimental feature flags turned on. This is as close as we felt we could get to doing that in Chef, and it solved a lot of those pain points we had with mysterious side effects coming from getting other people's changes that you weren't really expecting to get. So the other piece to this workflow, on top of having that feature flag ability, is the ability to monitor and debug what goes on. As I mentioned, trust but verify, so we need to have visibility into what's going on, and it also is really handy when stuff breaks. So this is example number one. As I mentioned, KnifeSpark has a whole bunch of plugins. We use IRC internally as our main communication mechanism. Because we have so many remotes, we actually default to using IRC for pretty much everything. This is our channel we call sysops announce, which is all the automated announcements from tooling and so on. You can see here, I was making a change to a cookbook called Pentaho. You can see I uploaded the cookbook, version 0.1.8, and then you can see when I promoted it to production, and what's snipped there because the URL is really long is it actually gives you a gist that shows you exactly what changed in that environment file. You can then see me committing and pushing it to Git because GitHub Enterprise supports post-commit hooks, which let you send it to IRC. And then what we're doing to deal with the two sources of truth problem is we're using a post-commit hook to fire up a Jenkins job, which runs a tool called knife inspect. I'm going to link to all these tools, by the way. It runs a tool called knife inspect, which checks that what you have in Git matches what you have on the Chef server. And you can see in this case it passed, and that tells me that both of those sources of truth are harmonious, like DevOps and stuff. Another thing we use for visibility is a feature of Chef called handlers. Handlers are essentially Ruby code you write to respond to a particular situation. In this case, we're dealing with something called an exception handler, which is when there's an exception in the Chef run, when an error occurs, run this code to tell someone or do something or whatever you like. In this case, we have it send a message to IRC that tells us the failure has occurred, and if there's an exception it can show you, it will give you a gist to that exception. So here we can see dbnest01 has been failing for 2 days, and here is a gist of what the exception was. We also augment the kind of, as I mentioned, Chef stores node state on the server, so you have like a reference point of what the state of the node was. We augment that with what we call last run information, which is information we're saving back to the server that lets you search for things like the status of the last Chef run, when it started, when it failed, what the exception was. And what that gives us that doesn't come natively is the ability, when we get that exception message, we can run a search query that says, show us all of the other nodes where the last Chef run failed with that exception. which is really, really handy when you run into what we call the inverted shark fin. This is a Chef dashboard. This is actually tracking a graphite metric of just the run status of Chef, succeeded or failed. This is the aggregate across all of our infrastructure. We have a number of cookbooks, for example, like syslog and LDAP and things like that, which live on every single server we have. And if you happen to be unfortunate enough to break one of those cookbooks, you will see the dreaded shark fin. The interesting thing here is, though, on this dashboard, you'll see a bunch of vertical lines. What those vertical lines represent are different kinds of code deploy. So you have red line, colors are a little bit faint, but you have red lines, which are, I believe, deploying the actual site code. You have blue lines, which are deploying site configuration, so that's like feature flags and stuff. You have yellow lines, which are load balancer and firewall changes, because we really got our network engineers into this whole monitor everything stuff. And then you have black lines, which represent Chef changes, the actual deploy part, which is the promotion to the environment where everything's looking at the thing. So although bearing in mind correlation doesn't always imply causation, in this case, because it did, what we can see is right before the start of the shark fin, you can see a black line showing you that somebody pushed out a Chef change. Further on the downward slope, you can see a black line where somebody attempted but failed to fix the problem. And then at the bottom, you can see a black line where somebody actually did fix the problem, and then you see the gradual recovery as our nodes start to recover from the failure. Having this visibility, like we said, trust but verify, this is super easy because we can tell at a glance, oh God, somebody broke a cookbook that's breaking Chef on everything. Like that has knock-on effects. You know, our other changes aren't going to be going out because Chef is all of a sudden failing everywhere. Because we have this information in IRC, we can also tell who made the change, when they made the change, and what cookbook they were working on at the time, or if they're working on one of the other artifact types that Chef has. So this whole trust but verify thing, we trust people to do Chef correctly, but you know, people make mistakes, softwares fail, complex systems fail. So what we end up with is the system where if the worst happens and Chef breaks, this change was actually me, by the way, full disclosure. What you actually end up with is now people can tell Cowie screwed up a Chef change, and if I wasn't already aware of that, say I went for lunch or something, they can let me know that my change broke something, come back and fix it. I'm going to upload these slides, but there's some links to the workflow tools here. Knife Spark, Knife Flip, Knife Last Run, the Whitelist stuff, and also I've upped the handlers that we use to talk to Graphite and IRC and Chef, the dashboard framework we use for displaying that last dashboard, and also Knife Inspect, which wasn't written by us, is super simple way to reconcile these two sources of truth. So the bit I'm going to talk about now is where we're actually at with that now. We've been running various stages of this workflow for a number of years. The Whitelist stuff only came out in 2014. And where we're at now is honestly, we are running into some pain points. We have a lot of Chef users. We have more than we ever have. The company is hiring more and more engineers who are working with Chef. We're starting to run into problems with change clashes. Although we have this workflow for visibility and stuff in the changes, the sheer frequency of changes is meaning people are running into each other. Somebody's uploading a cookbook, another person's uploading the cookbook, and now they both want to do whitelist changes and promotions, and they run into these problems. We're sometimes running into, even with all the visibility we have, we're running into confusion over a state of change. Imagine if somebody's uploaded a cookbook, and maybe they're still using the testing environment, but what you see in IRC is Jon Cowie uploaded cookbook Pentaho blah. You don't know, have I gone for lunch and forgotten to do the promotion, or am I testing, or am I in the middle of the change? Like, you actually have to come and ask me, and bear in mind we're very remote heavy. That might mean you have to ping someone on IRC and hope they notice that. Like, that does cause some problems occasionally. People forget things. Sometimes people forget to push their code to Git. This actually particularly hits me. I work from the UK normally, so my working day is 5 hours ahead of everybody else. So I start work at about 4 a.m. in New York, which is where most of my colleagues are based. And occasionally I will get up in the morning and try and make a Chef change and find that the last person out at night forgot to push their code, but they're in bed and I can't wait. Well, I could wake them up, but I'd be kind of an asshole if I did. So you run into things like that too. That causes friction, and it causes, you know, it blocks people. We still have testing pains as well, because although we are using whitelists, we don't really have any kind of formalized unit testing or anything. Because all of our infrastructure is on-premise, long-lived infrastructure, containerized testing we haven't had a huge amount of success with, because it doesn't always guarantee, for example, we tested against all the kernel versions we actually have running in production, so we're still having some pains around that. But to quote the $6 million man, we can rebuild it, we have the technology. So with that in mind, I would like to talk a bit about what I'm calling my 2016 $1 million workflow. We're currently in the middle of starting our annual planning process for next year, because we're a relatively large company now, not compared to like Target, but we're not 5 people. we have to go through like a whole annual planning process, budget, resource requirements, et cetera, et cetera. So this is what I'm aiming to do next year. I say we. We're aiming to move to using Deploynator, which is our deployment tool we use for literally everything else in our, pretty much all of our stacks, apart from Chef. I saw a great talk by Jez Humble at ChefConf this year, where he said one of the signs you're doing continuous deployment wrong is if all of your deployment processes aren't using the same tool chain. And I was like, Etsy kind of do a lot of continuous deployment. Like, I sort of feel like we should be doing it right. So I would like to move us toward, and this also lowers developer friction, I would like to move us towards a system where we're using this Deploynator-based workflow, which everyone's familiar with, all the developers learn from the ground up, and it stops them having to learn all the Chef vocabulary I just had to explain here. We also use this thing called a push queue, which is literally just we have a bot that manages the topic in our push IRC channel, which lets you tell what stages of deploys people are at, when they did it, if the deploy is in pre-production, if it's in production, if it's running tests, if it's done. It also combines multiple people into the same deploy. We'd also like to start unit testing. As I said, that's generally recognized to be good practice in many areas of this industry. We also do this thing internally called Tribased testing. Try is a special CI system which essentially lets you run a command called try locally, which uploads a diff of your local changes to a special Jenkins instance, which will run all of our unit tests against your local change before it's gone into Git. That's super useful for getting people to test. We actually use this, interesting story, for our Nagios deploy process as well. Come and ask me about that if you use Nagios later. This try-based testing lets us run all of our tests before we actually push any code. And as I said, this will make it more like our existing configuration deployment workflows. All of our engineers, when they want to do Chef, have to learn an entirely different set of language, an entirely different set of tools, and that's a little bit suboptimal, to be honest. We can do better by them. If we have the tool they learn on day one, like we have this push production code on your first day thing, if to make a Chef change, they need to use the same tool they used for that, that's a much lower friction approach. As like Harry was talking before about reducing risk, lowering friction. The risk part doesn't really play into it so much because we have the whole trust but verify thing. Like largely, if you want to make Chef changes and have access to do so at Etsy, ask and ye shall receive, essentially. Like we're not so worried about reducing the risk there, but lowering friction is definitely something we could be doing a much better job of. This hasn't been done yet. This is what I'm hoping to do for next year. And part of the promise I'm making, because I'm standing here talking about what I'm hoping to do, is to actually come back and tell you all if it worked. Because sometime, maybe it won't. I don't know, we haven't done it yet. It might be the case we discover a whole bunch of pain points in that process and we end up doing something totally different. So as Catherine mentioned earlier, I wrote a book called Customizing Chef, which is basically about, as I mentioned, Chef is designed for you to, not designed for you to drop it into your infrastructure as a one-size-fits-all solution. It's designed from the ground up for you to be able to customize and extend and bend it to your will. And this is the book I wrote for past me. I wish I'd had this book when I was trying to do all those things with Chef. So I'm trying to write that for those of you who are at that problem now. So I do have a few minutes left, and there hopefully will be some time left for questions at the end. But I'm going to now take advantage of the fact I have a captive audience. And I've heard of this thing called Minnesota politeness, which means none of you are going to get up and walk out. To rant for a brief moment. Now, originally, I'd planned on this rant basically being an extension of what John Willis was talking about yesterday, where he was talking about harassment in the tech industry, and his rant largely consisted of knock it the fuck off. Knock it the fuck off, by the way. But then I saw somebody tweet yesterday about how we talk a lot about empathy in this conference, and nobody's really talking about how you learn empathy. So I thought I would augment my rant a little bit with some actionable advice for learning some empathy. So this, as with a regrettable number of things in the tech industry, is aimed at the straight white men in the room. If you identify with all three of those words, please raise your hand if this is a thing you think about. Before I tweet open source software or go to an event, I first have to consider my personal safety. Not a single person in the room raised their hand. The problem with this industry, and it's a really fucking big problem, is this industry is dominated by all those people who didn't raise their hand. The people for whom this is a problem is every single other person in this room. I guarantee you there is someone in this room who has done something on the internet and got a death threat as a result. I have friends and colleagues who, before they open source something, have to consider, am I going to unleash an internet hate mob who's going to threaten to track me down and I'm not going to tell you what they threaten because it's kind of mean. I have a friend and colleague who did a talk and had to consider a particular word choice in that talk in case it unleashed an internet hate mob. Like, that's fucking broken. But here's the problem. Not a single one of you raised your hand when I asked this question, which means not a single one of us, the dominant group in this industry, have the first fucking clue what that's like. Which is why you'll hear people say things when people complain about harassment on the internet. You'll hear them say things like, they didn't mean it, or like, just ignore it, it's not serious. To quote Sarah Sharp, who is a developer, when men in the tech industry say trolling and harassment are just a part of being online, or just ignore it, or stuff like that, that's privilege talking, because when we get harassed, straight white men, we get harassed for things like, you're an idiot if you think Emacs is better than Vi. I guarantee you, when I step off this stage, no one's going to be telling me on Twitter that my admittedly fashionable shorts make me look inappropriately sexy. No one's going to be telling me that when I get off this stage, my tone came across as patronizing or like a school teacher or something like that. I'm 6'2", I have metal in my face, and I look kind of like a biker. My personal safety is not generally something I worry a great deal about. But if I tell someone else that just ignore it, they didn't mean it, that's essentially completely overusing my privilege to talk about something I know nothing about. But here's the thing. The other facet of the fact we have the privilege that this harassment does not affect us is it's a lot easier for us to say this is not okay, which is why I'm standing here saying it's not okay. Nobody's going to threaten to kill me after I say this. The massive problem with the industry is that the majority of the industry is straight white men. This does not largely affect us on a personal level. It might affect our friends or people we know. But we go through life assuming, because we don't see the evidence, that everybody else has the same opportunities that we have, that we assume when a female colleague stands up on a stage, they will do their talk, people will give them good feedback and good questions, and that is the experience they will have, which is not true. But because we don't see it, we don't tend to think about it much. Here's the problem. If we don't speak out, our inaction essentially says, we see nothing wrong with this. Like, the one area of the tech industry which needs more straight white dudes is fixing the fucking tech industry. It's like the only area we haven't taken over yet, and we really should. So how do we actually do something about this? I'm standing up here saying we need to be speaking out and stuff, but what do we actually do about it? Number one is education. Educate yourselves. But on that note, I would like to quote from our very own Bridget Cromhout. Assuming an arbitrary woman wants to educate you about sexism is essentially like walking up to an open source contributor and basically asking them to provide you free tech support, okay? We have the privilege to be in a position where we don't generally have to spend most of our days worrying about our personal safety. There are lots of people out there who do, who have written about it in great detail. Bridget's blog post is an excellent place to start. There's a publication called Model View Culture, which essentially is written entirely about diversity and sexism in the tech industry, and a whole bunch of other things that don't affect the dominant demographic in the tech industry. But you're probably sitting there thinking to yourself, well, I have a very comfortable life. I have a very comfortable life. It would be very easy for me to ignore this, because essentially, if I start speaking out about this stuff, if I start calling out when I see a female colleague at a conference getting hit on at a bar, when I hear someone giving them, there's this thing called mansplaining, which is a tendency we all have, which is when we hear a woman say something we disagree with, we'll talk down to them when we explain it in a kind of like paternalistic manner. We address that very differently than we tend to do with male colleagues, and it's really toxic. Things like that, like doing something is harder than doing nothing. So I would like to let Kate Huston speak for me when she said, if it seems hard, that's because it is. This is your first lesson in being what a minority with an opinion in the tech industry is actually like. Incidentally, Kate's blog post is an excellent resource, which is designed for men to start talking about diversity and the pitfalls you'll run into, things like mansplaining. Things like when you say something like, it's hard being a minority in opinion with the tech industry. Kate said that better than I could. I could easily have put that up on my slide and presented it as my original thought. but she said it first. So I'm amplifying her voice as a minority group in tech to basically give her the credit for her original thought. Like, this is something very easy for us to do. If you see women talking in tech about how somebody's struggling at the moment, there's a particular incident that happened. For example, there's like the well-known case with Ellen Pao, the CEO of Reddit, and the experiences she had at Kleiner Perkins. Amplify the voices of people out there. Call shit out when you see it happening. John raised a couple of issues the other day about people who had had death threats and been driven out from the tech industry. One of the most active members of the Docker community wrote a blog post the other day saying, I'm basically sticking with the tech industry despite the fact people essentially keep sending me pornography and death threats. That's fucked up. And it's also fucking broken. And the people who can fix it are the people it least affects. We are the ones who have the privilege to be able to talk out about this stuff from a position of safety. And if we don't do it, we're basically keeping the industry broken. Thank you, and questions. We may have no time for questions. I'll be at the bar later if you have questions. I kind of stopped you from asking any. Sorry about that.
That was amazing, Jon. Thank you so much. I'm sure that people do want to talk about everything that you added at the end of your talk, which I really appreciate. But I also don't want to stop. Two questions. We'll have two questions about the content that you actually flew all the way from the UK to talk to, though I very much appreciate the fact that you also added a few things.
Any chef questions?
But since you did have a lot of stuff about chef, I would like to give you the opportunity to answer a couple of questions about that before we go to our break. Right in the back here.
So the question was whether Chef Whitelist, whether the actual whitelists are in version control themselves, and if we have similar workflow issues. The actual JSON that you saw there uses a feature in Chef called data bags. For those of you who don't know, data bags it's essentially a feature Chef has to let you store just arbitrary JSON things like lists of stuff like IP addresses and passwords. So all our whitelists are actually in the data bag, and they're committed and pushed to Git as well. We tend not to run into so many clashes with them because we have we added the ability to Spark. When you change a data bag, it shows you a diff of what changed. Because you're only changing one file there instead of a cookbook that potentially has a whole bunch of different recipes and stuff in it, it's much less of a problem than it is with wider cookbooks, but it's essentially entirely driven by data bags. The question was, do we end up with clashes since data bags are versioned in Git but not on the server? Occasionally. There is a new feature coming out in Chef. It's kind of in the embryonic stages of actually being productionized now, called policy files, which is aimed to take all of the good bits of data bags and rules and get rid of all the bad bits. I'm sure the people at the Chef booth and or me will be happy to talk to you more about that. But it does happen sometimes, just not as much as it did with cookbooks.
All right, let's see if we have time for one more.
Anyone else?
I'm sorry, I thought I saw a hand over there.
I'll be around all day if you want to catch up with me later and talk more Chef and stuff.
All right, wonderful. Give it up for Jon.